Thank you for joining us today. My name is Mary Haskett. I'm the moderator. I'm a serial entrepreneur and the CEO for BeehiveID. This is my third startup. My last one I sold to a defense contractor, and then I went on to work in that world for a few years before deciding that it was really not for me. I'm also an urban beekeeper. Just a couple of housekeeping notes. You've all figured out you're all muted, and we do that just to keep things calm and sated, but obviously you can raise your hands by clicking on the icon or type questions, and then we'll unmute everyone at the end so that we can do a question and answer session for everybody. And we're very informal, and this is a fairly technical conversation, so feel free to ask questions if you have any. And we'll also be sending out the slides. You can either follow us on Twitter and we'll tweet them out and you get them that way, or we'll send you an email afterwards, and if you'd like, you can reach out to Rich Orcutt and he'd be happy to send you a copy. Our speaker today is our CTO, Dr. Alex Kilpatrick. He's the inventor of the BeehiveID algorithm. He has a tremendous depth of experience in the field of identity. He started his career in the Air Force, where he earned his PhD in computer engineering. He went on to manage the Air Force's research program in computer science. After he left the Air Force, he did research for DARPA on social network analysis, and then went on to work for a defense contractor developing large-scale biometric identity systems for foreign governments in the Middle East. He's made dozens and dozens of trips to Iraq, Kurdistan, Afghanistan, all the best stands. And the BeehiveID technology is a result of his desire to apply some of these technologies to the online world. And with that, Alex, please take it away.
All right, thanks, Mary. Just to set the context for this picture, this is Mary and I in a Black Hawk helicopter in Baghdad, Iraq, where we were working on the national identity system for the nation of Iraq, and we also did the same thing in Afghanistan. It was a lot of fun. As far as today, we want to talk to you about traditional fraud prevention and why we feel that it's costing people customers. And hopefully the goal of coming out of this is you'll have a kind of a different way to think about fraud prevention and how we do this kind of thing online. So I want to start out and set up a scenario. Let's assume that you're a banker, and what you want to do is you want to create accounts, you want to get lots of people to come in and give you deposits so that you have money to make loans. But at the same time, you don't want people using your bank for criminal activity, and the government doesn't want you using the bank for criminal activity, so you want to try to avoid that. Well, luckily, the government tells you exactly how suspicious you should be with something called the Suspicious Activity Report, and this is a government requirement that tells you what you should be looking out for in terms of suspicious banking activity. And one of the things they look at is whether you make a cash deposit more than $10,000, because that's indicative potentially of drug use or some other kind of illegal activity. Seems pretty simple. But in reality, it's actually kind of complicated. So you can't make a $10,000 deposit automatically gets reported. But it turns out you have to report other things as well that are also suspicious. For example, the $9,999 deposit gets reported as well, because that's also suspicious. Other types of deposits where it looks like you're trying to get around the law by doing, like, say, two $5,000 deposits are also suspicious. Or if there's something about the scenario that doesn't add up, that could be suspicious as well. And there are things that are clearly fine. Like if you do a $100 deposit, that's not going to be suspicious at all. But what it really comes down to is that trying to determine suspiciousness and what's good and what's bad is a lot more complicated than when we would think. And it turns out that this is a type of problem that occurs all over the place in the real world. And in statistics and computer science, we talk about this as a binary classification problem. Binary basically means two, so this is trying to divide things up into two categories. There's lots of things that we want to divide up into two categories, and this little graph here is an indication of a sort of a simplified binary problem where we're trying to classify these X's and O's. And that little equation there will tell you exactly whether something is an X or an O based on the number axes right there. It doesn't really matter what the numbers are, but if you know X1 and X2, you can instantly tell whether something is in one category or the other. And that's what we would hope that these problems would work like, or would look like. In reality, they look something more like this, where we've got these two different classifications and we try to separate them out, but in reality there's a huge gray area in between. Some things are clearly on one side, some things are clearly on the other side, but there's a lot of things that are kind of in between. And this is what a real type fraud prevention problem really looks like. The thing to remember about all this is that in any real-world binary classification problem, it's never as clean as we want it to be. It's never easy to divide things up into two categories. So in most of the spaces that we work in, we're going to talk about, for lack of a better word, scammers and good customers. And because we have to identify what's a positive and what's a negative, it's kind of arbitrary. We can define it whichever way we want, but for the purpose of this discussion, since we're talking about fraud detection, I'm going to define a positive as a scammer. So we're trying to detect scammers, that's a positive. If we don't detect a scammer, that's a negative, that's a good customer. So that leads us to two types of errors. The first is what's called a false positive. That means we classify somebody as a scammer when they aren't. That's bad because we lose customers. We basically turned away a good customer because they have some indication that makes them look like a scammer, and we don't have time to investigate them, so we're just going to reject them. Happens all the time. The other case is what's called a false negative, and that's when we classify somebody as a good customer when they're a scammer. And that's bad because we lose money or we poison our community or all kinds of other things. And again, either one of these are bad. We'd love to optimize both of them, but in reality, usually we can't optimize both of them at the same time. And what we try to do is minimize them as much as we can. So I want to set up a scenario for you. This is a really interesting aspect of this. Again, we're going to shift over to medicine for a bit, and I'm going to posit a new disease, and it's called Alexitis. And Alexitis is a very rare disease. It only affects 1 in a million people, so it's very, very, very rare. But luckily, we have a test that's 99% accurate. And I can't really just say 99% accurate without defining what that means. So in this case, what we're going to talk about is we're going to say if the person actually has Alexitis, then the test is positive 99% of the time. If they don't have Alexitis, then the test is negative 99% of the time. And that's what we mean in this discussion when we say 99%. If somebody ever tells you that they're just X accurate, you have to really dig down and understand what that means behind the scenes for that thing to mean something mathematical. Okay, so let's say I have come down with, I've been tested positive for Alexitis using a home kit I got at Walgreens. What are the chances that I actually have it? And think about this for a minute. You know, we've kind of given you some numbers here. We've thrown out, the number of people who have it, the accuracy, and things like that. So it should be pretty easy to figure it out from this. And interestingly, if you talk to doctors about this, if I gave an actual doctor about this, about doctor the scenario, about 74% of them would say that that if it's a 99% accuracy test and I test positive, then there's about a 99% chance that I have it. So basically, I'm screwed. I've got Alexitis. But it turns out that most doctors are actually wrong on this. The real answer is 0.01%. So I've tested positive on a 99% accurate test, and it actually turns out that there's a 0.01% chance that I have this actual disease. And I'll go over this kind of quickly because the math gets kind of complicated for the first time you've seen it, but I'll highlight the positives here. So this is what's called a truth table, and this is, if we test 1 million people, this is basically all of the outcomes we'd expect. So we tested 1 million people here. And of those 1 million people, we want to look at the ones that tested positive. Of those 1 million people, 1 will generally test positive, and that's what we call a true positive. However, a test that's 99% accurate is actually, another way to say that is that it's 1% inaccurate. So that means 1% of the time, we will test people as false positive. So over 1 million people, we've tested 10,000 as false positive. So in reality, of all the people that test positive, only 1 out of 10,000 were actually, or 1 out of 10,001 were actually the person who has the disease. And that's where we get this 0.01%. So even though I had what seems like a very accurate test, because it only affects a small population, when I actually test positive for that particular disease, I probably don't have it. It's a very, very counterintuitive thing, and it takes people a long time to get used to this. However, this is what's called the paradox of the false positive. And it happens anytime you have a case where something has a low probability of occurring in your population. It's dependent upon a concept called conditional probability. And the simplest way to think about this is with an example. So if you live in the United States, you probably speak English. I think everybody would agree with that. However, if you speak English, you probably don't live in the United States. And that's because there's so many people outside of the United States that do speak English. So this is an example of conditional probability. And without thinking about conditional probability, anytime you're thinking about these classification type problems, you're probably thinking about them in the wrong way. So thing to remember here is that if you're testing for something that rarely occurs, in a lot of cases like fraud, your tools have to be really, really good. Otherwise, you're going to have a lot of false positives. And that actually has nothing to do with the tools. It's just a function of math. unless your tools are really good, you're going to have false positives.
So let me make sure I understand this. When you say a false positive in fraud, we're saying that they're fraudulent and these are actually good people who would be a good customer.
Exactly, yeah. The false positive, again, is we're turning away customers that are actually good, and that's not good. Okay, so before I get into the rest of the talk, I need to make sure everybody's on the same page about how the internet works. And I know there's probably different levels of skill here, so I tried to come up with a really simple diagram to describe how the internet works, just to make sure they're all on the same page, and I hope I'm not insulting anybody with this diagram. So this is a real simple view of the internet. To understand it, you just have to understand bridges, transport packets, routers, host networks, gateways. Yeah. Okay. So in reality, this is kind of a view of how the internet works, but for this discussion, you don't really need it. This is a much simpler view of how the internet works. And I actually got this from a kid's book, and I love it because it's so simple and it actually kind of makes sense. So if we think about a website like a house, and if you have this is your online website or application or whatever, we can think of a domain name as an address, and letters as being things that are transported by little postal workers on the internet. And then the web host, not that important. But the thing to think about the internet as is think about it as analogous to the mail system and not analogous to the phone system, which is a common misconception. In the phone system, if I pick up the phone and I call you, I'm talking about the old wired phone system, I have actually a complete connection all the way from my phone to your phone through a bunch of intermediate switches, but it's one persistent connection all the way to you. The internet doesn't really work that way. The internet is more like letters that are sent from somebody to your address, and then you send them a letter back. The internet is basically built on packets, not connections, and that's going to be kind of relevant for the analogy that we're going to talk about in a minute. So what I want to talk about is a few different sort of transactional-based fraud techniques that are used and describe them in a simple analogy and then kind of describe where they break down. So one of the most common is something called IP geolocation. And IP is Internet Protocol, but it's basically about your internet address. So the analogy for this one is that, I'm worried about scams coming to my house, so if I see mail from Nigeria, I'm just going to ignore it because I know it's likely to be a scam. And, that would kind of work in the mail system. We would just be able to say, okay, return address Nigeria, ignore it. But on the internet, we don't really have that kind of addressing. We have numbers instead. So not a big deal. We have codes instead of numbers. That means all we need is just a way to look up that code to a country. And something like that exists. Given a particular packet that comes on the internet, we can look up the code that's associated with it and map that to a country based on databases of where different addresses are assigned and things like that. So in our mail analogy, we know that 891,889 is in Nigeria, and then we just reject that letter, that packet, and everything's fine because we don't want any business from Nigeria. That all works okay, except sometimes that database gets stale. Things change. Maybe 891,889 was assigned to Nigeria before, and now it's assigned to Germany. So now we're actually rejecting people that we would like to have business with, and maybe we're not rejecting Nigeria anymore because that database changed. So that's one of the problems. Another problem is the Nigerians will figure this out pretty quickly, and they know, okay, they're not accepting mail from Nigeria, so I'm going to send mail to my friend in France and ask him to just forward it for me. And that's what happens a lot of times is that packets get forwarded to a different location so that they will appear like they're coming from a safe location. So that's a problem. A second problem is that maybe, instead of sending the mail directly, I'm going to send it to FedEx and ask them to I'm going to send a whole bunch to FedEx and have them just to send one packet to the other city and then dump it into the mail system. And what that ends up doing is make it, makes like all the mail look like it came from one place. And this is sort of analogous to our cellular data because cellular data isn't geolocated. The IP address for the cellular data is the cell phone provider itself. So we lose a lot of that ability to map those addresses back to countries. So that's the other area where this breaks down. And as it turns out, IP geolocation actually works fairly well for honest users. You can use it to customize things fairly accurate at the nation level, less accurate for city and things like that. But if you want to sort of customize your web page to say, oh, you're coming from Texas, let me highlight things from Texas for you or whatever, that works okay where people aren't trying to mask where they're coming from. However, in terms of fraud prevention, it'll only catch the really clueless fraudsters who haven't caught on to this, and it's pretty useless for mobile data. And the reason it's not going to catch it's only going to catch the clueless fraudsters is it's very easy to mask the location of where your packets are coming from. So okay, so we were able to, once we realized that, we can just say, okay, well, we'll solve this with another database. We know that, this particular address is being used to send false packets. We know that letters are going to Nigeria, or going to France and coming in like they're coming from France, but they're really from Nigeria. So we'll just build a database based on that and then reject those, and thinking that this will solve the problem. So this is proxy or VPN detection online, which again is trying to solve the problem of people getting around IP geolocation. The problem with that, though, is it's the same kind of problem again, is that database gets stale, and even more so than the actual IP database, because the addresses in the VPN detection are much more fluid. The other problem with this is that on the internet, it's kind of designed around packets and routing and everything else like this. I can always route my packets to a location that looks clean. I can map them to a computer at my house, or a computer at my work, or a botnet or something like that. So it's really easy, much easier so than it would be actually to mail physical letters, to get my packets to look like they're coming from wherever I want to do, or wherever I want them to be, and there's no way for you to ultimately really be able to tell that if I do it even halfway well. So another technique that people try to use is cookies. And the analogy I'm going to use here, a little bit tortured, but the basic idea is that if I know you're a scammer, I'm going to kind of sneak into your house and put a little invisible X on all of your letters, so that I know that if I see those, I don't want to accept them. And a cookie on the internet is basically just a little piece of data that's dropped onto your computer, usually used for customization, to know like maybe what color scheme you like, or your preference, and so on, for different personalization of websites. And it actually works pretty well for that. We can personalize a website by just recording some data about the user. When they come back, we'll know that that was that particular user and what they like. The problem with this is that it requires permission effectively from the user. And when people are going to Amazon and all these places and they're dropping cookies, they don't really care. They like the fact that Amazon remembers some things for them. However, that only works because they're allowing it, or implicitly allowing it by not preventing it. It's very, very trivial to prevent this, because we're putting files on their computer. All they have to do is run in incognito mode, or a dozen other little plugins that will basically block the cookies or fake them out, or different things like that. So not very effective for preventing scamming. Another technique is behavior detection. And to carry on an analogy here, maybe we know that all of the bad email comes in between 3:45 and 4 o'clock. So that might be okay. We can start to reject that email, based on the fact that this is what happens. The problem is that behavior detection is very, very difficult to do well, just because so much behavior can be negative or can be positive, just depending on the context. So, for example, if you go back to the earlier example I had of deposits, a $9,000 deposit could be somebody trying to get around the reporting requirements, or it could be somebody just that was happening to make that kind of cash deposit. In the dating world, I've talked to different customers, and they said one of the things they look for is, did somebody sign up, with a credit card really quickly upon joining the site? And that's something that fraudsters do, and they might kind of reject that. But the problem with that is that it's also something that legitimate people do if they're really enthusiastic. So now you've basically taken somebody who's a legitimate customer and really eager because they just signed up and wanted to give you money really quickly, and you said, I think you might be fraudulent. So you're either going to reject them, or you're going to really make them mad, one of the two. And that's the problem with behavior detection, is that behavior is a very, very fuzzy thing, and depending on the context, it can be scam type behavior, or it can be legitimate type behavior and look exactly the same. The last one we're going to talk about is what's called browser fingerprinting. And to keep with our analogy, this is basically, let's say we decided that we can investigate the fiber content of envelopes that come from Nigeria that have a certain pattern on them. And we're going to reject those kind of envelopes because we know that they look a certain way and we don't want that. Now, interestingly enough, to segue a little bit here, this actually does work. You can fingerprint paper in a way that's just as accurate as a human fingerprint, which I think is kind of fascinating, but that's not what we're talking about here. In browser fingerprinting, what you're doing is you're basically looking at characteristics of the browser that make it somewhat unique among other browsers. And one of the things they look at is the number of fonts you have installed, the order that those fonts were installed, and other things about your plugins and all that. And that can actually make your browser look more or less unique depending on what's on it. Like, for example, my particular browser combination only occurs 1 out of every 2 million machines, which is a degree of uniqueness and might give you some indication of uniqueness, but it turns out it's not really all that unique, certainly not unique enough to identify a person and reject them or control their behavior that way. It will definitely lead to false positives. It's also not very useful for mobile because those browsers, mobile browsers, don't do the same kinds of things. They're much more constrained. It's also very trivial to circumvent with either a clean browser install or a virtual machine. And if you look at these techniques, and there are other techniques, I've just sort of hit a few of them here. Other techniques work different ways, but they all have kind of the same characteristics, namely that they are actually pretty useful for identification in the case of somebody who is not trying to circumvent your approach. So transactional data can be really useful for identifying a person if they're willing to cooperate. It's much less useful when they're not willing to cooperate. So to clarify, when we talk about transactional data, what we're talking about is data that is sort of part of a single transaction. So it's all tied to a single transaction, whether it's the IP address, the behavior, the type of your browser, all these things are all tied to a transaction. And this is useful in a lot of cases. It has some strengths that I definitely want to mention because it's not completely bad. One of the main strengths that it has is that it doesn't require user involvement or knowledge. This is all happening on the back end. They don't even know what's going on. And it's quick. It can be done in probably just microseconds, depending on the amount of data that you're comparing. You know, you can look at a lot of data with it, and the main thing that makes it advantageous is that it doesn't affect the user experience. It doesn't slow them down. I mean, not as far as part of the transaction. Obviously, if you reject them, it affects the user experience quite dramatically. And then you can also test on sample data to figure out how well it's working. But we think it has a lot of significant weaknesses. It's actually pretty easy to work around. I mean, and it's not something that requires a lot of knowledge to work around. It's just, you know, do this and then you won't have to worry about it. Based on the customers we've talked to, there's a significant false positive rate, and in a lot of cases as high as 20 or 25%. So all of those things have to go back and be either manually verified or you're just automatically rejecting good customers and hoping that you can make it up with volume. It's also difficult to aggregate this kind of thing across, you know, platforms. And fundamentally what this really comes down to is that with transactional data, you're relying on information that the person you're trying to block ultimately controls. All of these things, IP geolocation, all these things are presented to you by the scammer. And once they know what you're looking for, and they generally can figure that out very quickly, they can present the data that they think you want to see in order to make them look like a legitimate person to you. And that's the real challenge. So our view on this is that we kind of take a different view on it and sort of turn the problem around and try to, instead of trying to come up with a better way to solve transactional-based fraud, we're basically saying that really what we need to solve is the identity problem. And if you think about how we deal with people in the real world, we really want to know who we're dealing with. I mean, when I talk to people and they say, I got this email from somebody who wanted to meet with me, and one of the first things that they'll do is go look them up on LinkedIn and try to figure out, do I know somebody who knows them? Can somebody vouch for them? Do they actually seem to have a presence on LinkedIn or Facebook or something like that? Do they seem to be a real person? And this is because this is just how we figure out trust online. You know, how we figure out trust through thousands of years of evolution is that we have to know somebody in order to be able to make these connections. All this stuff is really important to developing trust, but online we really just don't have a framework to make this work. And that's the problem that we're working on. So in our view, we've really been, in terms of fraud prevention, we're trying to solve the wrong problem. We're trying to figure out, what attribute is this and that, and that's this cat and mouse game back and forth. But what we feel is that we don't have a transaction problem, we have an identity problem, and that's where we're going to get to trust from. Now, in terms of identity, people have been talking about this for thousands and thousands of years. Plato had a really interesting discussion about a fictional thing called the Ring of Gyges, and that's basically a ring that's invisible, probably from what it seems like the foundation for the Lord of the Rings story. And the idea is this is a very seductive thing. If you have a ring that lets you be invisible, then you're going to do bad things with it, and people would think you were crazy if you weren't, because why wouldn't you if you can basically get away with something bad and not have any consequences for it at all? And it becomes sort of a discussion of morality and what prevents people from doing bad things. Is it the fear of punishment, or is it morality? And not to get into that discussion here, because that's certainly a much more complex, different talk, but the way people behave seems to be that they're much more concerned about accountability than they are about morality. And all of the research that's been done to this so far seems to really support this. The social accountability is what makes people behave properly in the real world and online. And I think the Lord of the Rings story also showed what most people do when they can have ultimate power. So just to give you a little snapshot of this, a little snippet of some of the work done on this, the LA Times did an experiment where they supported both regular anonymous comments and Facebook-based comments at the same time on articles, and they sort of compared them to see, how it worked. And what they found, not surprisingly, was that the Facebook-based comments had much more rational, kind of civilized discourse than the anonymous comments. And this is an example of comments about some issue with the LA City Police or something like this. And you can see on the left that it's just sort of a rant that's laden with profanity and all of this, just terrible discussion, not anything that you would call a rational discussion. On the right is the Facebook-based discussion, and what was different about this one is it required people to use Facebook to make their comment. So they had to attach their comment to their name and their picture, so they actually saw their picture, their name, and the comment. And just that little tiny change had a dramatic change to the civility of the discourse itself. And it's a fascinating result and sort of fits with what we think of how society works in general. But just something as simple as attaching your name makes you think about what you're saying online, because now you can potentially be held accountable for what you said, even though a lot of people on that comment stream may not have any idea who you are. So looking at the identity problem, it's a very, very complex problem, and people have been solving it in all kinds of different ways. And it turns out that identity is something that's really kind of a spectrum on how we solve this level of problem. And this is sort of a cartoon that sort of illustrates part of the spectrum of identity. At the left, so we're looking at increased identity assurance. At the left, we have self-attested identity. And this is the majority of what we have online right now, is you go in and you say, I'm Alex Kilpatrick, alex.kilpatrick@gmail.com, and I've asserted that identity, but it's actually a really, really shallow identity. It's just an email. It doesn't mean anything at all. It's no connection to any other Alex Kilpatrick. So that's the most shallow of identity. At the other end is you have something that's been documented through the government. Like, for example, maybe I've gone to a notary and they've checked out all my identity documents, or I've gone to a bank and provided a passport or things like that. And it turns out there's a whole spectrum of things in between that basically give you different degrees of identity and different contextual identities depending on what you're trying to do. And the stronger identity, the more trust you have, but also the lower privacy you have. And that turns out to be really significant to solving this problem with identity. Now, to give you an example of sort of an extreme identity case, if you look at the process for a DoD top secret clearance, this process takes about 1 to 2 years, and it involves around 40 pages of documentation, all kinds of connections to different federal databases, including the banking database, and it involves dozens of interviews with people that you've known you for more than 10 years. And not only do they interview people that you've told them about, they'll ask those people if there's other people they should interview. So they're going back and trying to really, really dig into your past in order to figure out who you are. And that's because something like a security clearance is incredibly important in determining whether somebody can be trusted. And even with all of this, which is a process that's tens of thousands of dollars, it's not perfect, but it is extremely strong identity. Now, when you look at identity across different things, the problem is the stronger your identity, you hit these other two factors in a negative way. So obviously the DoD security clearance, very strong identity, also very, very high friction. It takes 2 years. It costs $15,000. If you want to eliminate fraud 100%, just do that. Just do the equivalent of the DoD security clearance for all of your new customers, and you won't have any fraud, or you'll have almost no fraud at all. Of course, you probably won't have too many customers either. And when you do that, you're also hitting privacy. When somebody goes through a DoD security clearance, they have no privacy at all. So what we're always trying to do is balance these two factors against each other. We can eliminate fraud completely by having a process that's so high friction, or we can have a process that's no friction and doesn't do identity at all, and then we're going to increase fraud. So we're always trying to balance those two factors against each other. Now, the problem with identity once you get onto the shallow end is that it can be mimicked with a lot of different techniques. So one of the techniques we recently learned about was something called an identity farm. And this is in the Philippines, this particular one. And what they do is they create Facebook profiles all day that are phone verified. They have SIM cards that cost about 3 cents, and they can verify the phone, to get that extra level of security on that profile. And the cost of one of these profiles, depending on how deep it is around 70 cents to $1.50, which is kind of amazing that it's actually worth that much. It tells you how much, social capital is worth these days. So at the shallow end, if we make our identities too shallow, then it's trivial to make a fake identity. Now what we're ultimately working towards is that this concept of if we can have a strong enough identity, then we can tie reputation to that. Reputation is just basically a history of actions on an identity. And then based on that reputation, we can evaluate trust. And then once we have that, then we can do all kinds of cool things online. So to give you an example of some of the things that we do and how we look at this problem, we do social, one of the things we do is social network-based identity validation, and we use Facebook for this, also Gmail and LinkedIn, but we're going to talk about Facebook here. Here's two public views of a Facebook profile that look, on the surface, about, not all that different. They're just people. Facebook public profiles are pretty shallow. You really can't tell much about them. But if you look at behind the scenes, what you'll see is that the profile on the left is dramatically different from the profile on the right. The profile on the left has very, very shallow connections, very, very little activity, while this profile has been around for a while, has very complex, deep interaction. And that's one of the things that we can do to be able to determine whether a profile is real or not. And the concept here is that basically what we're talking about is something that we're calling federated identity. And the basic concept is analogous to PayPal and other payment services. When you use somebody like PayPal, what you do is you trust PayPal with your sensitive credit card information. And then that allows you to make payments at other sites without giving those sites your sensitive credit card information. They just exchange a token. What that allows you to do is kind of sort of control your trust. You can trust Facebook with your credit card information. That's kind of their core business, and they're going to probably do that pretty well. What that in turn allows you to do is go to these other websites like a mom and pop florist, for example, and do a payment there without having to worry about them having your credit card information and using the default password of admin or something like that and having a data breach. So in an analogous way, an identity provider like us, we basically can validate an identity through a bunch of different dimensions depending on how deep that wants to be. And then we can assert that identity to a website. And that particular website doesn't even necessarily know anything about that person. They just may need to know that it's a real person. And so with this concept, this information can be restricted through here to the website, and no sensitive information has to flow back and forth. So again, just like PayPal provides payments to a website, we provide identity. Now this approach has a couple of different advantages. If you do it right, you can basically have one identity through per person without any privacy loss. You don't have to share any information with the site that you're operating with, and you can still assert a strong identity. It can be transportable across different sites, but ultimately it's all owned by the user, and that turns out to be a really key thing in this kind of space. So to give you a quick illustration of how we do this kind of thing, this is one of our sign-up pages for one of our clients, and they use either Facebook or photo-based verification. And the Facebook login, or the Facebook-based verification, is very simple. Somebody clicks on the button and they get the standard Facebook login pop-up that everybody's used to seeing online. And then behind the scenes, we do the complex analysis that you saw with the graph visualization. And we can say, yes, this is a real profile, or no, this was either a fake profile that was created to scam somebody, or a profile that's effectively never been used, which is, for these purposes, kind of the same thing. The other thing we can have somebody do is upload a picture. And a picture is another type of assertion of identity. Now you might tend to think, okay, this is a weak assertion of identity because I can get a picture from anybody, but we've sort of thought of that part. And the way selfie-based authentication works is that we ask somebody to basically just upload a picture of themselves holding a piece of paper with a code written on it that we've given them. And it's a short use code, and obviously we don't care if it's in the mirror, we can handle that. And what this does is we can do a couple of things with this. The code itself validates that they were there when the picture was taken, because they didn't just get a picture off the internet. They were, or at least a person was there to take that picture and hold the piece of paper and everything else. we have a lot of technologies we use to detect Photoshop and things like that that are pretty strong. So that gives us two things. We know that it's a real person and not a bot or not, somebody creating 10,000 accounts. We know it was a real person. We also know that they were there when the picture was taken, and we use biometrics on the face itself to make sure that somebody isn't creating multiple accounts. So this is where we get to the one account per person thing, which turns out to be key for reputation. Because without a restriction of knowing that we only have one account per person, if somebody behaves badly, all they have to do is leave, create a new account, and come back. One account per person means that when you ban somebody, they can't come back, and that's really key. So some of the advantages to the type of approach that we're doing is it's very, very low friction. It's single click for Facebook, or they can take a picture with a selfie and just instantly upload it. And as we know from the internet, people are really great at selfies. They're producing like 10 billion of those a day, so they know how to do it. It's a very simple approach. We can guarantee uniqueness through biometrics, and this is an area that we've got extensive experience in and how to make that work. We can actually do, whether it's Facebook or selfie-based authentication, we can do it with no private information. They don't have to share anything with us that's sensitive. And then because we actually know that these are unique people, we can start to do trust between people, and somebody can recommend somebody else and have that actually be a meaningful thing. We can also do it as one-step integration with the site through just a simple link or a simple callback. Now this is our really low friction, kind of low simple or lightweight, what we call lightweight identification. We can make this arbitrarily more complex by tying it to more real world documents or other kinds of verification if that's what you want. But this is something that can be done in a very, very lightweight way without hardly impacting the user acquisition process at all. So to sort of summarize what we've talked about here, I kind of want to hit the key points, and hopefully, again, this will make you think of things in a slightly different way. Important things to think about. So classification problems are inherently fuzzy, whether it's fraud or no fraud or anything else. They're always fuzzy, way more fuzzier than we want them to be. And that's why we have these issues with false positives and false negatives. Anything that's fuzzy means that we can be kind of too far on one side of that line and classify somebody the wrong way. And what that ends up making us have to be concerned about is that when we're looking for something that's rare, like perhaps somebody creating a fraudulent account, we have to be more precise to be able to handle that, because otherwise we're going to be ending up with the paradox of the false positive and have all kinds of false, we're going to be turning away good customers. The other point is that transactional data, which is how most fraud detection is done right now, is dependent upon data provided by the scammers. And they control that data. The legitimate people aren't going to be trying to cover it up, but the scammers will be, and they're going to make themselves look like legitimate people. So before too long, you won't be able to tell the difference. And then finally, kind of our view on this thing is that identity is really the foundation of trust in the real world, and that's what we need to be working towards, is how can we figure out easier ways to identify somebody to know whether they're trustworthy, instead of looking at these shallow transactional-based markers and trying to build trust based on that. But for identity to work, it has to be low friction, it has to preserve privacy.